Hello, my name is Noel McKellick, and I'll be introducing the Case 3 presentation for our team. This team consists of Calvin, Heidi, Courtney, and Dustin. So Case 3 is framed around the dilemma of a professor who is considering at which age that she can retire and be the most optimal economically. The factors going into this decision are the PIA, which is the annual allot benefit from the Social Security Administration. The second factor is the expected value of these earnings, and these are based upon the life expectancy table. So how long is this retirement period going to last? Is it going to be a long time or a short time? And the probability associated with those different ranges. And lastly, the last factor is the age of retirement. So age 62, age 66, and age 70 are being analyzed. And the main consideration of this problem is if she retires too early, receives a lower annual benefit, she may outlive the optimized range of that benefit. Whereas if she retires too late, she will receive a higher annual benefit, but may not live long enough in order to realize the optimized annual, the increased annual benefit. Going forward in this presentation, we're going to cover an incremental analysis that was done comparing the expected value for the different retirement ages. We'll also go over how to interpret a change in present value and what a change in present value means. We'll also go over what to do about the uncertainty in the results. How should the uncertainty of the age of death play into this decision? And lastly, we'll provide an overall recommendation for the professor at which age they can start collecting Social Security benefits. On to you, Heidi.
Thank you, Nolan. I'm Heidi, and I will get started with the discussion. So right here is our graph for incremental NPV versus the standard deviation. Incremental NPV is on the y-axis, and the standard deviation is along the x-axis. We got our data for this graph from the table to the right side here. With this information, we can see that the expected value for retiring at age 66 is over $6,000 versus the expected value for retiring at 70, which is below negative 6,000. This is a huge difference, and it means that retiring at 66 will give you a better monetary outcome than retiring at age 70. We can also see the standard deviations here. So for retiring at age 66, the value is around $33,500 versus at age 70, it's around $36,700. The lower standard deviation is what you want. So in this aspect, retiring at age 66 would also be more beneficial than age 70. However, it is important to note that the standard deviations are much higher than the expected values, and this could be a bad sign. Thank you, and I will turn it to Calvin to continue the discussion.
We must understand what the change in present value, also known as incremental present value, reveals to us. A positive change in present value indicates there is more value in waiting to collect Social Security benefits. Conversely, a negative change in present value indicates there is more value in collecting the Social Security benefits earlier. The table on the right shows the incremental present value calculated for our professor for each situation given an age of death shown in the first column. The second column shows the incremental present value to be had in waiting until age 66 to collect benefits, compared to starting benefits at age 62. Similarly, the third column shows the incremental present value to be had in waiting until age 70 to collect benefits, compared to starting the benefits at age 66. Since the incremental values are negative until age 81, we know that the highest present value comes by starting benefits at age 62. However, if the professor lives to age 81 or older, we see a positive incremental present value by waiting until age 66 to collect. If the professor lives to be age 86 or older, we also see positive incremental value by waiting even longer and starting benefits at age 70. Since the age of death is not known for our professor, we must calculate the expected value of the NPV given the life expectancy probability tables to make the best decision. Now Courtney will discuss how the standard deviation of the expected value reflects the risk that our professor is taking.
Thanks, Calvin. Now, let's take a look at the standard deviation and its relativity to incremental present value. Looking at our table, you can see that we calculated our standard deviation to be 33,538 from ages 66 to 62, while for ages 70 to 66, we calculated 36,784. Both of these numbers are relatively large when compared to both incremental net present values, which are about 5 times less. When dealing with standard deviations, the higher the number, the less certainty that we have. So in this case, we have no idea when a person's going to die, so making a decision on when to start receiving those Social Security benefits, it's challenging because there's no universal answer. Therefore, with both age groups having a high standard deviation, they both carry a high level of uncertainty and risk. Now looking at the two different age groups, we see that 70 to 66 carries the higher value. Therefore, it carries more risk. The longer that we wait to receive our Social Security benefits, we have a higher level of risk of dying before maximizing our benefits. Now, I'm going to hand it over to Dustin to talk about what our professor should do for her retirement.
Thank you, Courtney. After reviewing the information and utilizing it to weigh the risk versus the benefit, we believe that our professor should not wait until the age of 70, but rather wait until age 66 to start collecting her Social Security benefits. This approach increases the amount our professor would receive compared to her deciding to start at age 62, as well as leaves some potential benefit on the table compared to waiting until age 70. But the risk associated with obtaining that additional benefit is much too high, and therefore the likelihood of receiving that full benefit is low. So in conclusion, we utilized the data published by the National Vital Statistics Systems for 2022, focusing on the mortality rate of a woman between the age of 62 to over the age of 100. With this data, and using the PIA for our professor, we were able to look at the incremental NPV for each benefit starting age, and then could calculate out the expected NPV based on the probability of dying at each age between 62 and 100. We were also able to calculate the standard deviation for both age ranges, those being 66 to 62 and 70 to 66. Therefore, with the review of all of the information, it shows that our professor should not wait until age 70 to try and maximize the benefit received, but should start at age 66 in order to receive the maximum likely amount based off of the mortality rate of a woman. Thank you for your time, and take care.